so sorry about that. Oh, there's something else I should say. I should say something. I told you about if you've got 2x minus 7 less than 9, it means that the magnitude should not be more than 9, right? And I said it means that if, for instance, if you've got x, a magnitude of x being less than 2, it means that the actual value should not extend beyond minus 2 to 2. Now, that idea also works for something like this. If you've got this question, 2x minus 7 greater than 9. So this is less than 9, this is greater. Now when you have greater, it means or. When you have less in this kind of problem, it means and. So we treated this as the and case. When you've got this, treat it as the or case. So it's going to be 2x minus 7 greater than 9 or 2x minus 7 less than minus 9. Do you see the relationship between this and that? So this one looks like the other problem we solved where we had an or problem, an or case. Now, how do you think, why should we agree with this? Because if I say that the absolute value of an x term should be greater than 9, what I'm telling you is that the distance between 0 and whatever x is, whether positive or negative, should be more than 9. So if this is our number line and this is the 0, and this is x, or this is minus x, we want the distance to be greater than 9. So I mean, if this is 9, every other thing more than 9 should work for for this problem, and every other thing less than minus 9, I mean, should work for the problem, because we want to make sure we are far away from 0 by 9. We are 9 far away from it. Okay, so that's just it. When you've got absolute value less than a number, you're looking at the AND problem. When you have absolute value greater than a number, you're looking at an OR problem, and you solve it the same way we solved the other questions. Now we're almost rounding up. Let's just is this going to be within, I'm supposed to look at linear inequalities for 2 variables, and in this case we solve, because it's 2 variables, so it's just like a simultaneous, it's just like a line where you've got y and x. I don't know if I should do this now or I should keep it for when we are ready to plot graphs, because you will need to plot graphs for this one. I will leave it till when we are ready for graphs. Okay, then the next thing to discuss is quadratic equations and quadratic inequalities, and we are done. That's it. So I will keep this to, we can discuss this when we are ready to discuss the graphs. But I'm tempted to talk about the, I'll just talk about it, briefly, because I want to make you see the relationship between this one and what we have just discussed. I know it's a lot to take in just about a few minutes, but I'm so sorry I had to give it to you right now. So linear inequalities with 2 variables. Now this is something you'll come across almost all the time. So solve for x and y in the problems below. Y is less than or equal to 2x plus 3. Number 2, minus 2x plus 2y is greater than 5. Solve these problems. They are not simultaneous equations, okay? They are separate problems. Solve this and solve that. Solving an inequality problem, like I said, means to show us how the graph will look like. Now, you cannot do this on a number line because we've got x and y, so it's got to be on an xy axis. So in this problem, you've got y less than or equal to 2x plus 3. Now, this is just telling you something. It's telling you that we've got something that looks like an equation of a line. Y equals to mx plus c. And also, it's telling you that we've got an inequality problem.
So because when you have